Hey 301ers, today we'll be talking about the effects of progressive resistance training on diseases such as multiple sclerosis. Multiple sclerosis is a disease that affects the neural pathways within the brain as well as between the brain and the body. Now, remember back to a previous module where we talked about the myelin sheaths surrounding nerves that aided in making a nerve impulse travel quicker. For individuals that suffer from multiple sclerosis, one of the biggest symptoms is a loss of coordinated movement, which results from the deterioration of the myelin sheaths. Because of this, researchers wanted to figure out a way to prevent this demyelination from occurring in the effort to slow the loss of controlled movements. One of the ways that they hypothesized that this could be done was through a progressive resistance training program to build strength that can allow an individual to increase their movement capacity.
So in the study, 35 participants between the ages of 18 and 60 years old were utilized. They were randomly divided into two groups, a training group and a weightless group. The training group began supervised progressive resistance training for 24 weeks while the weightless group continued on with their regular lifestyle. After these 24 weeks, the training group stopped their supervised training and continued on with self-guided PRT, and the weightless group began their supervised PRT. This continued on for another 24 weeks. The supervised PRT consisted of 4 lower body exercises including horizontal leg press, hip flexion, leg extension, and prone hamstring curls. This training also involved 2 upper body exercises, which were the cable pull down and the cable tricep extension. Throughout the study, the subjects were tested 3 times. These tests consisted of a walking test, a sit-to-stand assessment, and a stair climbing test. And they were performed before any training had begun, after 24 weeks, and after 48 weeks.
The results produced was that the training group significantly improved neuromuscular function of the knee extensors and flexors, which translated to improvements in functional capacity. Furthermore, the improved functional capacity was maintained after 24 weeks of self-guided physical activity. The weightless group produced similar patterns of changes after PRT. Compelling evidence is provided that PRT performed over sufficiently long periods improves functional capacity, likely due to neuromuscular adaptations.
There were 2 main take-home points from this article. The first being that it's possible to maintain the positive effects of the experiment for extended periods of time. This is accomplished by continued progressive resistance training from the experiment. Secondly, those who continued training without supervision succeeded through community-based, self-guided physical activity. By exercising in groups, they were able to motivate and learn from each other. This is important because those with MS can use this training as long-term intervention for rate of force development, which can improve balance and lower risk of falling and injuring themselves.